Okay, so today's lesson on fractions, we are going to learn how to multiply fractions. So we'll start here by just looking at the rules. Note here at the bottom, we do not need to find a common denominator. Common denominator was only required for adding and subtracting fractions. Okay, so rules for multiplying fractions. Firstly, if you have mixed fractions, convert them into improper fractions. Next, we're going to reduce the fractions, okay? And I'll show you how we can reduce by finding the greatest common factor. Next, you can multiply the numerators, which are the top parts of the fraction. You just multiply those together. Then you're going to multiply the denominators together. Those are the bottom parts of the fraction. And then the last step is convert your fractions back to mixed fractions if necessary. And if you have to do any more reducing, then make sure you do reduce to put your fractions into lowest terms. So let's take a look at our first example here. So I'm going to show the two methods of working with these fractions. So the first method is you just multiply your numerators together. So you get 3 times 6, which is 18. And then we just multiplied 8 times 5, which is 40. All right, so all we've done is multiplied our numerators together, and then we multiplied our denominators together. Now you can see that we can reduce this fraction. We can reduce by dividing by 2. Both the numerator and denominator get divided by 2. So 18 divided by 2, that gives me 9. And then 40 divided by 2, that gives me 20. So take a look at this fraction. Can it be reduced any further? We can't reduce it any further, so that would be your final answer. So that's the first method, is just go ahead and multiply your numerators, multiply your denominators, and then reduce. The only problem with that method is you might run into very, very large numbers, and it'll take a long time to reduce at the end. So this rule here, rule number 2, it actually requires you to reduce before you multiply, all right, by finding the greatest common factors. So I'm going to show you that method next. So let's just show it here on the bottom. I'll just make a line across. It's the same question though. All right, so we have here 3 over 8, and we're multiplying it by 6 over 5. So what we're going to try and do is reduce here. And you can reduce diagonally. All right, so look at the numbers diagonally. 3 and 5, we cannot reduce, but 6 and 8, we can reduce. The greatest common factor here we can use is 2. So if we take 6 and divide it by 2, just show it here, we end up with 3. And here, if we take the 8 and we divide it by 2, we end up with 4. So now our new fraction, or our new fractions look like this: 3/4 times 3/5. All right, last step. Now we're just going to multiply our numerators together. So 3 times 3 is 9. And then we're going to multiply our denominators together. 4 times 5, which is 20. And we end up with the same answer. So 9/20, 9/20. So looking at our next example, we have 3/4 times 14 over 15. So I'm just going to rewrite that out. So 3 over 4 times 14 over 15. All right, so let's multiply. So we'll do the first method, which is just multiply the numerators together. 3 times 14, which is 42. And then we have 4 times 15, which is 60. Okay, so we multiplied our numerators together to get 42. We multiplied our denominators together to get 60. All right, so now you have this fraction that can be reduced further. So finding the greatest common factor, we'd have to divide by 6, top and bottom. So 42 divided by 6, that gives me 7. And then 60 divided by 6, that gives me 10. All right, so our final answer is 7 over 10. We can't reduce any further. So let's take a look at that same Let's look at the same question, and we're going to reduce first. So we have 3 over 4 times 14 over 15. So look at the fractions, right? 3/4 we can't reduce. 14 over 15 we cannot reduce, but we can reduce diagonally. All right, so look at 3 and 15. 3 and 15 we can reduce. 3 and 15 have a greatest common factor of 3. So 3 divided by 3, that just gives me 1. 15 divided by 3, that gives me 5. And then 4 and 14, those can both be reduced as well by dividing by 2. 14 divided by 2 gives me 7, and 4 divided by 2 gives me 2. So now you can see what our new numbers will be for our fractions. It's 1 over 2 times 7 over 5. And now we just multiply our numerators together. So 1 times 7 is 7, and then 2 times 5 is 10. So we end up with the same answer, both methods, but by reducing here, you're working with smaller fractions, and then you're not reducing at the end. All right, so just the question you guys just tried. Like I said, if you ever get stuck, just multiply your numerators together. Just multiply 4 times 5 together, and then multiply the denominators together. All right, so 4 times 5 is 20, and then 3 times 16 is 48. And then lastly, you just have to reduce. All right, so we can reduce by dividing by 4, top and bottom. Divide by 4. So 20 divided by 4 gives me 5, and then 48 divided by 4 gives me 12. All right, so we get our answer of 5 over 12. Now you could have done it the other method, which is to reduce first. And so 4 over 3 we can't reduce. 5 over 16 we can't reduce, but we can reduce diagonally. We can reduce the 4 and 16 diagonally. The greatest common factor of 4 and 16 is 4. So 4 divided by 4 is 1. 16 divided by 4 is 4. So that gives our new fraction of 1 over 3 times 5 over 4. Now we just multiply the numerators together. 1 times 5 is 5. Multiply the denominators together. 3 times 4 is 12. All right, either way, we still end up with the same answer. So looking at our third example, we have 1 over 3 times 10 over 12 times 3 over 7. So we can still do the same first method, which is just multiply the numerators together. So 1 times 10 times 3, and then we can multiply the denominators together, which is 3 times 12 times 7. All right, so 1 times 10 times 3, that gives me 30. And then 3 times 12 times 7 gives me 252. So we are working with larger numbers. All right, and it might take you some time to reduce. Here, I can reduce both the top and bottom by 6. Divide both the top and bottom by 6, and I get my answer of 5 over 42. All right, but we can do this the other method, which is where we reduce first. So I'll show you that as well. So we have 1 over 3 times 10 over 12 times 3 over 7. All right, so we can't reduce the 1 over 3, we can't reduce the 3 over 7, but we can reduce the 10 over 12. We can also reduce the 3 and 3 diagonally. So let's take a look at that. So the 3 and the 3 can both be reduced, giving us 1 and 1. All right, next we can reduce the 10 and the 12 by dividing by 2. So that gives me 5. 12 divided by 2, that gives me 6. All right, so our new fraction is now 1 over 1 times 5 over 6 times 1 over 7. All right, so 1 times 5 times 1 just gives me 5. 1 times 6 times 7, which gives me 42. All right, so again, we do end up with the same answer. All right, so when we have a mixed fraction, we go back to our rule. Our rule number 1 stated to just put them into improper fractions and then multiply. So here we have 2.5 times 3 3/4. So 2 times 2 is 4, plus 1 is 5. So that gives me 5 over 2. And then we're going to multiply it by 3 times 4 is 12, plus 3 times 15 over 4. All right, so here, can we do any reducing? We cannot. 5 over 2, we can't reduce. 15 over 4, we can't reduce. We can't reduce diagonally either, so we just have to multiply. So multiply numerators together. 5 times 15 is 75, and then 2 times 4 is 8. So it is an improper fraction. We just have to put it back into mixed fraction. So how many times can 8 go into 75? 8 can go 9 times, and then we have 3 eighths. 9 and 3 eighths. Okay, so this example, so we've got we got 3 fractions. 2 of them are mixed fractions here. So let's change them to improper fractions. So 1 1/5, that becomes 6 over 5. 3 3/4, that becomes 15 over 4. And then we have 3 over 7. All right, so we are going to end up with large numbers if you just want to multiply. So we have 6 times 15 times 3. That'll give me 270. And then 5 times 4 times 7, which gives me 140. All right, so reducing this, just going to divide by 10, top and bottom, which gives me 27 over 14. We can't reduce this any further, but we can put it back into a mixed fraction. So how many times can 14 go into 27? Just once. And then we have 13 over 14. So 1 13/14. Let's do this question where we can reduce. So I'll just make my line here. So same question. Okay, so we'll have our 6 over 5 times 15 over 4 times 3 over 7. We can't do any reducing when we just look at the fractions, but we can reduce diagonally. So the 5 and 15, we can reduce by dividing by 5. So that leaves me with, I'm just going to change my color. That leaves me with 1, and then 15 divided by 5, that leaves me with 3. We can also reduce the 6 and 4 by dividing by 2. Okay, so 4 divided by 2, that's 2, and 6 divided by 2, that's 3. All right, then I just like to rewrite my fractions just to show you what they look like. All right, so 3 times 3 times 3, that's 27 over 14, just like we had here. And then we can put it into mixed fractions. So 1 and 13 over 14. All right, so our first question here on this slide, if you have 8 over 12 times 3 over 4, you can use either method. So 8 times 3, that's 24. 12 times 4 is 48. And then just make sure you reduce. All right, 24 and 48 can be reduced by dividing by 24. So top and bottom can be divided by 24, which gives me 1 over 2. Okay. I'm just going to make a line here so we can keep them separated. Okay, next we learned that of means to multiply. All right, so we are multiplying 1 over 6 times 3. So it looks like this, 1 over 6 times 3. Now, any whole number is just over 1. So if you ever get confused with whole numbers, just put them over 1. Okay, now you can go ahead and just multiply your numerators together and multiply your denominators together and then reduce. So let's just do this one that way as well. 1 times 3 is 3, 6 times 1 is 6, and then we're going to reduce that. 3 and 6 both can be divisible by 3, so we end up with 1 over 2. All right, so final answer is 1 over 2 again. And the last question, so again, of means to multiply. So 2 over 5 times 3 over 7. We can't do any reducing here, so let's just multiply our numerators. So 2 times 3 is 6, and 5 times 7 is 35, and we can't reduce any further, so our answer is left as 6 over 35. All right, so for this question here, we have 1 and 2/3 times 2 and 2/5. We're going to put that into improper fraction. So 1 times 3 is 3 plus 2 gives me 5 over 3. And then 2 times 5 is 10 plus 2, that's 12 over 5. So you can just multiply your numerators together and multiply your denominators together. But for this one, let's just show you the reducing again, the reducing method. All right, so 5 and 5 can both be reduced to 1 and 1. And then 3 and 12, greatest common factor is 3. So this would be 1, and then 12 divided by 3, that's 4. So if you look at this now, you're left with 1 over 1 times 4 over 1. Then you can multiply that. 1 times 4 is 4, and then 1 times 1 is 1. And remember that any number over 1 is just the numerator itself, so the answer would be just 4. All right, now if you did this where you just multiplied your numerators and then multiplied your denominators, you would get the same answer once you reduce. So let's just look at that method as well. So 5 over 3 times 12 over 5. Multiply the numerators together. 5 times 12, that's 60. Multiply the denominators together. 3 times 5 is 15. And then you can just reduce this. All right, 60 divided by 15, your answer is just going to be 4. Okay, so for this one here, the first thing we're going to do is convert it into improper fractions. So 4 times 2 is 8 plus 1. That gives me 9. The denominator stays as 2. Multiplied by 1 times 6, which is 6 plus 1 is 7. And the denominator stays as 6. All right, so for this question, let's do reducing. Okay, we can't reduce 9 over 2. We can't reduce 7 over 6. So now we can reduce diagonally. We can reduce the 9 and the 6. We can reduce it by dividing both of those by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. All right, so now our fraction looks like 3 over 2 times 7 over 2. Now we can go ahead and multiply. 3 times 7 is 21. 2 times 2 is 4. Can't reduce it, but we can put it back into a mixed fraction. How many times can 4 go into 21? 5 times, that's our whole number. And our denominator is 4. So 5 times 4 is 20. We need 1 more to get to 21. So our answer is 5 and 1/4. All right, so we're going to stop here.